Hello again, everybody. Alan Shura here, and it's May 10th, 2017. So this is the ordinary way of connecting a motor to a generator. We've got 2.4 volt, 3.06 amp. Well, what I have here is a renewable energy generator. I don't really know what to call it yet, but I've tested this for power, an increase in power with the addition of a circuit to the previous configuration that was acceleration under a load, the motor generator. Please go back to that video if you want to see that portion where this configuration can accelerate and increase power even without this addition of a circuit. And I'm not showing the circuit because I don't know where I'm going to go with this when it comes to commercialization and distribution. I want to see this get out there and for the technology to advance, but this was a successful test. I did a test a couple of days ago I used an analog amp meter here. Today I'm going to use the digital amp meter so that I don't have to break this up. And for those of you who, some of my viewers have commented on measurement and whatnot, well, this is in line. It is in line to the power supply, the amp meter here. And I'm going to register the volts with this, which I trust, and it is separate from the power supply reading. Now this power supply, if you put a battery on it, it'll show 6 volts if the dials are down to 0. Here the dials are up a bit and they're set to 17 volts potential within the power supply. They will remain that throughout the test. So that is one of the controls of the test. I will test the circuit in this portion of the video, which you can see some of the wires coming out from it. And then without the circuit. So without the circuit is the control to see if the circuit adds anything to the accelerator motor generator combination. So as I said, this test was successful in that it showed an excess of power. So I'll get on with the more exciting part, which is the working with the circuit here. There we are, 17, and we'll start it up. All right, so there we are. We're registering 2.17 volt, 2.23. The volts are being taken right at these alligator clips that are on, and so is the lead to the amp. So this does not agree. It tends to show the total power in the system. The amperage tends to be much higher than the power supply. So these are two totally separate power measurements. These two are separate from that, but they both show a gain in power in this test. So we'll quickly write them down before this accelerates very much and get on with the test. Okay, so we've got 3.07 and 3.1 for the power supply. Now it's showing around 3.2, so I'll put 3.2. And then on here it's showing 2.72, 1.80. Okay, now we'll put a light on. Okay. You can see it. That's this is actually with the circuit attached, but not using the circuit. So I put the light on. Put the light on, it slows the motor right down. And there's no brightness in the light at all. Okay. So we got our measurements there, did we? Let's put that there. Okay, slow it right down. It's 1.6 volts, well 1.5, 3.07. And there. 0.75, 1.80. Okay, so that was without the circuit actually, though the circuit is actually connected in this, and that has a bit of an effect, very little, but now we'll connect it to the circuit. So we've seen what the accelerating motor generator will do. Before you can hear it starting to accelerate a bit. So I'll try the other circuit with the circuit and you'll see the increase. Okay, now we'll do it with the circuit attached with the light. Recall that without the circuit, the light would not even light at the very same power input or similar input. That light is lit and it almost looks to full brightness. Now we'll take the readings with the light. 12.8, or I mean, we'll say 13.1 at 3.07. Oops. And the digital readings, now we'll take the digital readings. That was the reading off of here. .0, which is pretty close. 1.8. Okay, we'll say it's slowing down a bit. Not much. But we'll say 12.0 times 1.8. Okay, now we've recorded our data. Now, just to see how it would react the other way, so you can tell visually outside of the instruments. Take the light off. Break the connection. Hello again, yes. Here we are with the same potential, and now I've taken the circuit completely out. So it's the same as the acceleration under a load video. And so after 5 minutes this motor generator configuration will accelerate, but we'll take the initial readings anyway. So you saw how the light was fully lit under the same potential. So this is the ordinary way of connecting a motor to a generator. We've got 2.4 volt, 3.06 amp, which is pretty close to our no load condition with the wire and different circuitry attached that was shown to accelerate this. So that's one control of this test. Another control is how much power does the light take to light up fully bright. And here it is, it's the same light. And we'll take it off the same potential again. 17 volts, which is throughout the testing. That's one of the controls as well, that the power supply remains at that level of wattage. So here we'll attach the bulb to that. There. And it's full bright too, the same as when the motor generator was running. And it's showing that it's taking, well, according to the power supply, it's taking 30 watts, which is supposed to be what it should be drawing. So 10 volts, 3 watts. So it's 30 watts, about. However, you recall that with the bulb going with the circuit, you've only got 12 volts times 1.8 amp. So that's only 20 watts to run both the motors plus the light. So we'll run the motors and the light without the circuit again, briefly, just to confirm. See? It does not even light the light without the circuit. Put so much resistance it could just about stop the motor. But you recall it was full bright with the circuit. And this is in the configuration that if you leave it, it will accelerate. So we'll add up our numbers here and see what we come up with wattage. Well, now we'll get into the summary of the test. So I did this experiment with similar results before the one we just did, but I have to add a control at the end of the test here. It's a power supply test to see how it's functioning. It's functioning under ordinary conditions. And since I'm not at my regular shop, I brought one of these motors to test it with, and I put the same power supply right after the test on 12 volt potential, and I use this motor, which is 15.5 1.3 high-speed DC motor, and I used the light bulb used in the test. And so just the motor without the bulb at the start is 12 volts, 0.7 amp, and the amperage decreases after 30 minutes and it settles into around just over half an amp, pretty steady. When you add the light bulb at that point after 30 minutes, the wattage increases to 46 watts. But you'll note the light bulb was at full brightness, and the amperage really increased under that bulb. This little motor, it might have a little generating capacity as well, residual, but the wattage may not have increased significantly with the renewable energy generator, but the wattage here went from 6.7 right to 46 watts with the bulb, which is rated at almost 30 watts. So it looks like the power supply was working normally. The motor reached momentum after about 20 minutes, and the amperage increased with the bulb. But in the case of the renewable energy generator, the amps were constant under all but one condition, with the most reliable measure, and on the system measure with the power supply also the amps were constant except for one condition, and it was the volts that were accelerated. And you'll note that here there's actually a decrease in watts when the light was added, a decrease in watts, and the amperage and voltage did not change a lot. But here there was a massive increase in watts, 40 watts increase, and here with the bulb added, it registered a decrease on the digital reading, and on the power supply, it registered an increase of about 8 watts, a small 7, yeah, almost 8 watts. But the control, the ordinary load at that 17 volt potential, it would be 30 watts consumption. But it only went up 8 watts, and here it actually appeared to go down. So all of the mechanical energy of the motor generator is accounted for, and it appears to be a net gain over the ordinary operation of motors and generators. So I'd like to see this technology go forward, and so I may have to get some funding support to organize and see that this technology moves forward. And we'll see how that goes, which is altogether a different phase in this. Okay, that's about summarizes it, and we'll take it from here.